Thanks, Walter.
Very much.
So the next, it's my fault. The next, because I was looking at the wrong version of the schedule. The next presentation by Samin Aref and Zachary Neal, it's detecting and analyzing coalitions by optimally partitioning signed networks of political collaboration. My excuses, Samir.
No worries at all. Can you see my slide?
Yes, sure.
All right, so my name is Samin Aref. I'm from Max Planck Institute for Demographic Research, and I'm going to present a joint work with Zachary Neal. So this work is about signed networks and balance theory. As many of you know, signed networks are those that have positive and negative edges, and according to balance theory, which is a theory that goes to 50s, 40s, and 50s, a signed graph is balanced if its set of vertices has certain properties, or if these four conditions are satisfied in the network. So here is an example, and the network in here is indeed balanced, which means that all these conditions are satisfied. And when the network is balanced, it also means that the set of vertices can be partitioned into two groups such that positive edges are within the groups and negative edges are between the two groups. But most networks we come across in practice are not balanced. So here is an example of an unbalanced network. But the interesting observation here is that oftentimes there are only a few edges that can be removed to make the network balanced. So in here, if we can destroy the friendship between Sarah and George, the network becomes balanced. So we express this idea more formally by saying that the network is one edge away from balance, or the frustration index of the network is 1, or the line index of balance is 1. So these are all the theoretical background for the work I'm going to present. When we remove this edge, what we get would be a balanced graph, and therefore we can partition the nodes into two groups based on the conditions I mentioned. Here is another example signed graph. The dotted lines are negative edges and solid lines are positive edges. There are different ways that we can evaluate balance in this network. One way is to look at different triads in the network. Here, one triad is balanced, one is unbalanced. And this would give us something that is called triangle index, the ratio of balanced triads over total triads. But another approach is, as I mentioned, based on partitioning the nodes into two groups such that most edges are consistent with the assertions of balance theory, meaning that positive edges appear mostly within the groups and negative edges appear mostly between the two groups. When we get this optimal partitioning, then we would see that there's only, in this example, there's only one edge that is inconsistent with what we expect. The edge 1, 5 is positive, but between the two groups, which are shown by two different colors. And this gives us the line index of balance. And we can normalize this value so that we get something between 0 and 1. And this would be comparable to the triangle index, meaning that if we get a value of 1 on the normalized frustration index or triangle index, it means that the network is perfectly balanced, and smaller values closer to 0 means that there's less balance. All right, so the topic of the work we did was on bill passage rate in the US Congress. So if we look at each chambers of the US Congress, we see that the fraction of bills that are eventually passed into law has declined over time. And our research question is why Congress has been so ineffective at passing legislation. So we have two rival hypotheses as two possible explanations for the answer to this question. So the first hypothesis is what we call party control hypothesis. And it says it should be easier to pass bills if the majority party holds a larger majority. And the second hypothesis says that it's the coalitions that matter. And when the Congress is polarized, into different opposing coalitions, it should be easier to pass bills when the largest coalition or the controlling coalition is more ideologically unified. All right, so these are the types of networks that we use in this study. We use bill co-sponsorship data, and from that data, we infer signed networks of legislators. So in these networks, the nodes represent legislators, and we have positive and negative edges, which represent collaboration between these legislators. Positive edges means a significant, statistically significant level of collaboration, and orange edges, which are negative, represent a significant lack of collaboration. And as you can see, Republicans are shown by red and Democrats by blue. All right. So when we look at the level of balance in this network, we see that over time, balance has increased. This means that over time, the networks have become more polarized. So this is something that is consistent with what we already know about the temporal trends in the US Congress. So this is more of a validation of the method that we're measuring what we want to measure. So what we're trying to do is to quantify partisan polarization in these networks and see whether this partisan polarization has an impact on bill passage rate or on legislative effectiveness. So both triangle index and frustration index showed that the polarization has increased, but it's only the second method, the method based on frustration and partitioning, that would tell us which legislator belongs to which of the two groups based on balance theory. So we can look at the composition of the group. So we do this optimal partitioning of the nodes, and then some nodes would appear in one group, the others in the other group, and then we would look at the composition of the nodes in the larger group, which we call largest coalition. So as you can see, this largest coalition is 50% or higher, so they have the majority, and because of that, they have the control. And as you can see, back in late 70s and early 80s, these coalitions had both Democrats and Republicans together in the same group. But then in more recent years, you see that these coalitions are mostly made up of Democrats or mostly made up of Republicans, because the bars, as you can see, are mostly red or mostly blue. So this shows the increase in partisanship. And the idea here is that coalitions, the way we define them, are not same as parties. And back in 70s and 80s, we had more of bipartisan coalitions. In more recent times, we have more partisan coalitions. So now we can look at the temporal trends of the network. So here in this animation, you see how the network is changing over time. And there are two observations we can have from this visualization. One is if we look at the colors on the nodes, we see what we had in the previous slide, that over time, blue nodes are appearing in one side and red nodes are appearing in the other side, which is the increase in partisanship. And if you focus on the colors on the edges, you see another interesting trend, that these two groups, these two coalitions, over time are becoming more polarized, meaning that there are more green edges inside the groups and more orange edges between the two groups. This is also something that we saw earlier in the slide where we measured the level of balance, and it was increasing over time. So essentially, these two observations show two aspects of the increase in partisan polarization. Now we're going to test the two hypotheses. So first of all, we use a simple bivariate association to see whether the decline in bill passage rate has been significant over time. And we see that it has been indeed significant. So we use two mediation models to test the two rival hypotheses. So we had the party control rival hypothesis and coalition partisanship. So the first model gives us no statistical support for the party control hypothesis. So this means that the size of the majority party does not matter, or doesn't help explain the decline of bill passage rate. And for the coalition partisanship hypothesis, we actually find the statistical support. So the partisanship of the largest coalition actually explains the decline of bill passage rate. So what we see is that the largest coalitions have become more partisan over time, and this increase in partisanship makes it easier to pass bills. And the only silver lining here is that if it was not for the increase for the partisan polarization, Congress would have been even more ineffective at passing legislations. So here are some references, and you may check out our open access paper, supplementary information, also data and code are publicly available. Thank you.
Thank you, Samir. It's been a pleasure. So questions for Samir to the participants?
Hi, I have a question.
Sure.
So sorry if I missed something, but I am assuming, so when you say that, when you look at this polarization and you use a social balance to study how they are polarized and justify the dynamics of this polarization, so am I right if I say that you're implicitly assuming that this polarization process is an endogenous thing in the Congress, it doesn't have an exogenous factor from outside of the Congress?
Well, our study doesn't say anything about whether the polarization is endogenous or exogenous. What we see is that polarization is also manifested in the patterns of political collaboration between these individuals. So essentially the data we have are from bill co-sponsorship data. So to legislate, we know for every pair of legislators how many bills they have sponsored together, how many bills there are that their names appear together as sponsors. And based on these patterns of political collaboration, we evaluate the structure of these collaborations as a network, and that network shows polarization, which is not surprising at all. I guess in the context of political science, no one would be interested to hear that, to see a very sophisticated and indirect way of showing such a well-known and pre-trivial observation. But we do this only as a validation of our method to answer the research question.
What I mean is that, so these edges that you have in the network that you construct are edges of the relationship between these congressmen and women inside the Congress. And so you have these dynamics of Hamiltonian that you construct with the side network based on the balance of these triangles inside the Congress. And so these are not, the agents here are not responding to the voter satisfaction and factors like that. So you're assuming that the time frame that the balance is happening is a time frame that these Congress representatives are inside the Congress and they're dealing with each other, not responding to the voters from outside.
Maybe I didn't explain properly where the edges come from. So so essentially we have a number for every pair of legislators. Let's say you're a legislator, I'm a legislator. We have sponsored 200 bills. The question is whether this 200 is statistically a very large number or a very small number or just a normal number. And if 200 is a lot, then there's a positive edge between us compared to the null model we use for inferring the sign network. So that number in itself doesn't mean anything, because there could be some legislators who are just interested in co-sponsorship, so their names appear a lot. Some people are perhaps mostly absent, so their names appear to, not very commonly. So essentially from this co-sponsorship data, we get the backbone of the collaboration structure. So the edges represent whether two people are collaborating significantly or avoiding each other significantly.
Okay. Thank
you
you.
very
I mean,
much.
I would be interested to see how this combines with these other studies that they study the response to the voter utility and how these representatives position themselves on the political spectrum in response to voter utility. But yeah, I mean, yeah, I think I got the answer to my question. It's clear. So you're, can I ask, is the data that you are working on that John Wilkerson database for with co-sponsorship?
No, well, I'm not totally sure because the data I particularly worked with was the network data, which you can find it here. But I guess the bill co-sponsorship data, I don't think there would be several versions of it. But yeah, the number of bills that are sponsored by every pair of individuals.
Thank you.
Any other question? I have a short question, Samir. Is there any way to classify, categorize these bills in themes or something like that, as we've seen in the first presentation in this slot, in order to observe whether there's a polarization around certain topics and not a polarization in others?
Yeah, definitely. But well, that was not something that we considered, but perhaps topic models could be used to also look at the content of the bill, and then we would deal with a more sophisticated network model that has perhaps positive and negative ties, but also on different topics. So currently for us, it would be positive or negative ties across all the topics. So two people who avoid each other must have avoided each other across different topics, meaning that regardless of their political affiliation, their names did not appear together. Their names appeared together much less than what is expected by chance, you know, so they must have avoided each other across different topics, across abortion and civil rights, and let's say every topic.
Okay, thank you. So we will leave it here. Is there any other question? Because we are, Emanuele, we're going to ask anything, or just tell me that the time is over. It's on a coffee break. We need a coffee break.